Geometry Chapter 7 Lesson 1, and I want to take a look at two applications of what we've looked at so far in this lesson, and that is how do we apply a ratio and how do we apply proportions. We'll look at the ratio first, and the type of problem that you'll see in applying ratio is if you're asked for the ratio of one item to another. Okay, so anytime in a problem where it says what's the ratio of this item to this item, another item, it's asking you to write a ratio. Okay, and there's three things that we need to remember when we're doing this. It's very important to remember. The first thing to remember is the word order determines the ratio. All right, so as we're reading that problem, we want to make sure that our mathematical ratio matches the word order that I'm asked to give. Okay, so it's very important that we pay attention to the word order. The second thing to remember is that the units have to be the same. Okay, so once we write the ratio, sometimes the unit of the drawing or model will be in inches, where the actual figure or item will be in feet. In order to write the ratio, the units have to be the same. So I'm going to have to convert either one into the units of the other. So in the case of inches and feet, I'm going to have to convert inches into feet or feet into inches, whichever one I would like. It doesn't matter. Normally going from feet to inches is easier because if you're in inches already, you're probably in a fraction of a foot, and so that's going to lead to a little bit messier working with the values because they'll be in decimal form. So usually feet to inches is a little bit easier to go. The third thing to remember is that we then, once we have the same units, we need to reduce. And reduce the fraction means there's no decimals in my answer. Okay, no decimals in my answer anywhere. I don't divide it in my calculator to get a decimal answer because that ratio doesn't really tell me anything. And if there's a decimal in the fraction, I'll need to remove that. And I'll do an example of that in just a minute. So when we're looking at ratio or writing a ratio, we need to remember these three things, and we need to recognize the problem as being a ratio problem when we're trying to solve it. So let's take a look at an example or two. As I look at this first example, it says that a photo is 8 inches wide and 5 1/3 inches high, and this photo is enlarged to a poster that is 2 feet wide and 1 1/3 feet high. What is the ratio of the width of the photo to the width of the poster? So the first thing I need to do is to determine how my ratio is going to look. And that's going to be determined by the wording of the problem. As I see here, it asks me what is the ratio, so I know it's going to be ratio of, and the width of the photo is the first thing mentioned. So that's going to be the first thing, or the numerator, in my ratio. I then see the word 2, and so after the word 2 is going to be the denominator. So the width of the poster comes second. So in my ratio, the width of the photo is going to be in my numerator, and the width of the poster is going to be in my denominator, and that is determined by the wording of the problem. And notice it says, what is the ratio? So I know that my answer is going to be a ratio. That's how I know that I'm writing a ratio. Now that I know what values go where, I go to the problem and I simply substitute the values in. The width of the photo is 8 inches. Whoops, I didn't want to cross that out. 8 inches, so I'm going to substitute 8 inches in for my photo. And then the width of the poster is 2 feet, so I'm going to put those two values in. So I've written my ratio according to the wording of the problem. I notice that the units are not the same, so I need to convert them to the same units. And again, going from feet into inches is usually easier because I'm not going to end up with any fractions. So 12 inches in a foot, 2 feet would give me 24 inches. Now that both of these are the same, I can then reduce the values, so both 8 and 24 are divisible by 8, which gives me a value of 1 to 3, or 1/3. So then my ratio of the width of the photo to the width of the poster is 1 to 3. Okay, so we had to do all three things there. We looked at the word order, we converted the units, and then we reduced our fraction. Okay, let me do one where we have a decimal and I can review how to simplify a fraction that has a decimal in it. If we take a look at example 1 in our textbook, it says the base of a pyramid at the right is a square whose sides measure 0.675 meters. The intent was for the sides to measure 675 meters. What is the ratio of the length of the base side in the small pyramid to the length of the base side in the intended pyramid? So again, I see that the question is what is the ratio, so I know that my answer needs to be a ratio. So I must determine what the order of my ratio is, and that's determined by the wording of the problem. It says, what is the ratio of the length of the base side in the small pyramid? So I have the small pyramid in my numerator, to, and then the length of the intended pyramid. So the intended pyramid goes in my denominator. So this would be my intended pyramid. So now that I know what my ratio needs to look like, I simply substitute in the values. So the small pyramid has sides that measure 0.675 meters. And the intended pyramid, we wanted 675 meters. So I have my ratio. I look at the units, they're the same, so that's okay. So all I need to do is to simplify this fraction. And I can never leave a fraction with a decimal as my final answer, so I'll need to simplify that. And the way to simplify that is to take the value that has a decimal and move the decimal however many places so that you change it from a decimal to a whole number. So the decimal being here, I move it 3 units to the right, or 3 places to the right. And because it's a fraction, I need to take this decimal that's here and move it 3 places to the right as well. So basically what I've done is I've multiplied by 1,000, both numerator and denominator, and now I don't have any more decimals. Now I can go ahead and simplify my fraction. So both of these values are divisible by 675. So the numerator divided by 675 is 1. The denominator divided by 675 is 1,000. So my ratio is 1 to 1,000. And what that means is the smaller pyramid is 1,000 times smaller than what we intended the pyramid to be. Okay, so that's one type of word problem or application problem you'll have, is where you're asked to write a ratio of one item to another. Let's take a look at how we can use proportions and apply those to a real-life example. Now, in order to apply a proportion, we need to talk a little bit about one other thing, and that's called a scale drawing. The scale in a scale drawing compares each length in the drawing to the actual length. Okay, so on any drawing, whether it be a map or an architectural design of a building or anything that we have a drawing of something that's in real life, we have to have a scale, because we can't draw the picture the exact same size as the real object. We don't have paper big enough. So we have to have a scale in which a length in the drawing represents a particular length of the real item. And then we have to use that scale for every side of the figure that we're drawing. That ratio of the length in the drawing, how long we make a line in the drawing, compared to the actual length, is called the scale. Okay, so if we take the length in the drawing and we compare it to the actual length of the item, this is called the scale. This is the scale of the drawing. Now, this ratio, as we've talked about before, can be written either way, whether the drawing, 1 inch, let's say, is equal to 3 feet, or we could write 3 feet is equal to 1 inch. How we write that doesn't matter. However, we do have to keep in mind what value is what. In other words, we have to keep track of which number is for the drawing and which number is for the actual. Okay? Which number for the drawing and which one's for the actual, we have to keep track of that in order to use this then to find out other values using proportions. Okay, so the important thing here to remember is that we have a scale, and this scale is a ratio of 1 to 3, let's say. I can then write an extend or a proportion by writing another value where this ratio is equal to this one. So all I have to do is multiply these by the same value in order to get it. Or if I know one, let's say I know this is 4 and I don't know what this is, we can use what we learned about solving proportions, the product of the extremes equal to the product of means, to then determine the lengths of different things. So let me do a couple of examples so you can see how this works. Let me kind of sum up here. Let me go back to this one here. So when we're talking about proportions, we need to figure out what the scale is, okay? And the scale is simply a ratio of the drawing to the actual, okay? So this is a ratio and this is called the scale. I then use this ratio to determine the lengths of either the real life object by taking what's from the drawing and calculating what that would be in real life, or I can figure out how long a line I need to make on my drawing by figuring out, well, if I know how long it is in real life, what would that be in my drawing? And again, I'm going to use the scale or that ratio in order to do that by setting up a proportion. Before I go to that example, though, there's one other thing I wanted to mention here is when you have a scale, when you're given a scale, you never change the scale. Okay? You never reduce it, you don't change the units, you don't do any of that. When you're going to use a scale to determine the length of something either in real life or the length of something that you're going to draw, the scale is a ratio, and you're going to use that to determine other lengths. So it is unlike this problem up here where we're trying to find the ratio of one item to another. We're not doing that. We're using the scale in order to calculate lengths in a drawing or lengths in actual life. So if you're given a scale and you're asked to determine the length of something, you're going to use proportions. You never change that scale. You leave the units different because you're converting something that's small into something that's bigger, so the units should be different because inches on paper is going to translate to feet in real life or something like that. Okay, so it's a different type of problem than what we were talking about here, and that's why it's important to know what type of problem you're doing. Are you writing a ratio, or are you trying to calculate the length of something from a drawing or from real life to a drawing or vice versa? All right, so let me do a couple of examples. So in our example here, we have the sandwich shop at the left, which is 40 feet tall. The shop is an enlargement of an actual milk bottle. The scale used to construct this restaurant was that 5 feet is equal to 2 centimeters. Find the height of the actual milk bottle. Now, we're not asked to write a ratio. We're asked to calculate the length of something, so we're not going to mess with this scale. We're going to keep the units, everything the same. So I'm going to write this scale as a fraction, 2 centimeters, 5 feet over 2 centimeters. Now, when I write my next ratio, all I have to do is make sure that I keep feet with feet and centimeters with centimeters. Again, how I choose to begin doesn't matter, but once we've written a ratio, every other ratio, if we want it to be equal to it, must be written in the same way. So the dimension given to me is 40 feet, so that must go in the numerator because I wrote feet in my original ratio. And then this is the value that I don't know. So now I have this proportion, which we know how to solve by multiplying the extremes and the means. Now I'm going to keep the units in place because I want you to see how you can tell what the units should be. Because remember, we've been talking about whatever you do with numbers, you can do with letters or even words. So when I multiply 5 feet times x, that means 5 feet times x is equal to, and then I have 2 centimeters times 40 feet. Okay, now I'm solving for x, so I'm going to divide both sides by 5 feet because I want the 5's to reduce and I want the feet to reduce, so that's why mathematically this works. So this is going to be 5 feet. Now I can reduce the feet with the feet, leaving me only centimeters. That's how I know my answer is going to be in centimeters. I can divide 5 into 40, making that 8. So now I just have 2 times 8 centimeters. So x is equal to 16 centimeters. So you can see if you write your ratios and write out the steps, you can actually do this pretty simply without a calculator, just by applying the properties of algebra that we know in reducing these things. So when we're asked to find the length of something, we're going to leave the scale alone. We're going to write it as a ratio, and then we're going to set up a proportion by writing a second fraction written in the exact same order as the original, and they'll always give me either a dimension of the actual or a dimension of the model, and in that case I should be able to figure out how far or how long something is. All right, so let me do one other example here of a problem that I'll expect you to be able to do. As we look at number 25, we're asked to make a scale drawing of the bedroom to help arrange the furniture. We're going to use a scale that 3 inches is equal to 2 feet. Your bedroom is 12 by 15 rectangle. What dimensions should your scale drawing be, or what should be the dimensions in your drawing? So again, we're asked to figure out the length of something, so we're not going to do anything with the scale other than to use it as our first ratio so that we can write a proportion. So 3 inches in the drawing is going to equal 2 feet of my actual room. So because I wrote inches to begin with and feet in the denominator, every other fraction must be written in the same way if I'm going to call them equal. All right, so my bedroom is 12 by 15. Now I'm going to have to do this twice because I can only use it once at a time, once to do the length of my room and once to do the width of my room. So let's do the first one, 12 feet. So because I'm using 12 feet, I need to line feet up with feet in my second fraction. So because the first fraction had feet in the denominator, I must put feet in the denominator of my second fraction, and then I have an unknown value in my numerator. Now I can go ahead and do my proportion. So the product of the extremes, so this is going to be 3 inches times 12 feet, is going to equal 2 feet times x. So I'm going to solve for x. So I'm going to divide this side by 2 feet, and I'm going to divide this side by 2 feet. The feet reduce, the 2's reduce, leaving me just x. Over here, the feet reduce with the feet, the 2 reduces with the 12, making 6. 6 times 3 is 18, and I have just inches left in my units. So in my drawing, I'm going to need to draw an 18-inch line to represent my 12-foot room. Now I'm going to have to go back and start all over and do the exact same thing again, only this time I'm going to use the other length of my room. So the other side of my room is 15 feet. So I'm going to line 15 feet up with feet again, and again I have an unknown value. So again, I'm going to solve my proportion by doing the product of the extremes is equal to the product of the means. I'm going to divide both sides by 2 feet because I want the feet to reduce and I want the 2's to reduce, leaving me x. The feet reduced. 2 doesn't go into either one of these, so I'm going to have to do this just by multiplying it out. 3 times 15 is 45, so it's 45 over 2 inches. Now I don't want to leave this because if I told someone to draw a line that's 45 over 2 inches long, that just doesn't make much sense. So this is where I would want to go ahead and come up with the decimal answer or mixed number. So when I divide that out, I'm going to get 22.5 inches as the length of my other side of my room. So on my drawing, I need to make the lines 18 inches by 22.5 inches in order to accurately represent the dimensions of my room. So again, we use the scale. We don't change the scale because we're going to use it to calculate something else. And how I write this determines how every other one needs to be written. I just simply line up the feet with feet and inches to inches. If I had written this the other way, I would just simply put these numbers in the numerator so my fractions are written the same way. I can then calculate this and arrive at the same answers using it that way. Okay, so again, as we're using these two types of problems, make sure you understand which problem and type of problem you're doing, because in one type of problem, we'll need the same units. In the other type of problem, we want to leave the units because we're using it to calculate something else. Make sure we reduce our fractions and make sure we don't have any decimals in our answers when we're writing a ratio. But when we're actually finding the lengths of something, then a decimal answer would be okay.